Thanks everyone for joining us for yet another session of the Data Heroes group. This week, I'm personally excited because this is one of the open source projects that I've been tracking for the last 2-3 months, particularly around SQL Plot, which Toby and Ryan have been building together. And when Toby came up with the SQL Mesh announcement over LinkedIn, I was like, yeah, now we need to have Toby speak to our product group as well. And that's how we are here. Thanks, Toby and Ryan, firstly, for joining us for this session. It's great to have you because you're building something that's very unique in the market today, addressing some of the most critical pain points in deployment. And I think I'll have a lot of questions for you, but then before I do that, I want to pass it on to you, Toby and Ryan, to introduce yourself to the audience, and we can take it from there.
Well, thanks for having us. Hey everyone, I'm Toby. I'm the CTO of Tobico Data. I'm excited to kind of present our work to you on SQL Mesh. Before starting Tobico Data, I led analytics and experimentation at Airbnb, where I worked on projects like Minerva, their experimentation or their metrics platform and their experimentation platform. And before that, I was at Netflix working on leading their experimentation platform. So I'll kick it off to Ryan to do a quick intro.
Hey everyone, Ryan Eakman. Thanks so much for having us today. Before this, I'm a software engineer at Tobico Data. Before this, I was a data engineer at Netflix. I worked on content and gaming there. And then before that, I worked in gaming at Blizzard and Riot Games as a data engineer and software engineer.
Fantastic, Toby and Ryan. Great backgrounds that you bring on. I think you worked on solving some real software data challenges and then probably building a product that really solves the data issues, right? So before we go ahead, perhaps the last issue from my end, I would share the link to our YouTube and our LinkedIn channels over the chat. So feel free to subscribe on it. And let's hear from Toby and Ryan. Let me stop sharing because I'm very curious to understand what is SQL Mesh all about and how it relates to data projects. And before I pass it on, Ryan, and open the floor for you, what exactly is DataOps in your point of view? Toby, Ryan, one of you can pick it up. What is DataOps? Because that's what you're solving in your world.
Sure. DataOps is the kind of practice of making it easier, safer, and faster for people to kind of ship data products, right? And so it involves things like CI/CD, testing, observability, etc., right? And so it's all about making it more efficient and safer to ship changes to your code for data.
Perfect. The floor is yours, and I'll come back with some interesting questions that I have around your project already analyzed. So, but before that, I would like to understand your perspective, what you're building at SQL Mesh, and we'll take it from there.
Sure. So yeah, we'll go over a couple of quick intro slides, and anyone can feel free to kind of interrupt and ask questions to keep this interactive. And after, we can do a really quick demo to kind of showcase basic usage of SQL Mesh. So at its core, SQL Mesh is a data transformation platform with a focus on DataOps. And so SQL Mesh was really built so that data scientists and analysts and engineers can all build correct and efficient pipelines. So our small team of around 8 people, we came from a lot of some larger scale companies like Apple, Airbnb, Netflix, and Google. And so we wanted to build a transformation platform that can work at any company, not just small startups, right? And so we took our experience from these companies to build SQL Mesh. So SQL Mesh really excels if you have scale in one of these 3 vectors, right? So if you're familiar with tools like dbt or other tools, they really work best with smaller companies where you have fewer use cases, like not too many models, if you have less people and less data. If any one of these kind of areas is larger for your particular organization, you're really going to feel the benefits of SQL Mesh. SQL Mesh was built for scale so that no matter what happens to your company, your data, etc., you're going to be able to scale with it. So at its core, how it works, and I'm not going to go through all this, but you can kind of ask questions or dig in if you're interested. One of the core technologies of SQL Mesh is the virtual data environment, right? It really allows you to easily spin up a new environment that you can kind of see your whole environment of your data, and it's very cheap and sufficient, right? You can do this at any scale. Real quick, I'm going to see a question. How is the correctness of a Python declared SQL Mesh, right? So these words are kind of iffy, but what I really mean here is that SQL Mesh is consistent in that whatever you define is exactly how we're going to do it. And so in particular, there's a lot of nuance with things like incremental models, right? You want to make sure that your incremental models don't have duplicates, they process correctly, right, etc. And so SQL Mesh has a lot of tools to make sure that whatever you define is exactly how we're going to do it. So moving on, SQL Mesh has semantic understanding of your queries, right? We actually parse your SQL, and we can do a lot with that, like automatic column level lineage, etc., right? And finally, we have automatic data contracts, right? So through kind of the semantic understanding, we're able to build out a complete graph of columns, etc., to make sure that all of your data is kind of correct and as you expect. All right. So I'm going to do a real quick overview of what a virtual data environment is, because I think it's going to kind of help you understand the demo a little bit better. So the use case is basically like, I'm a developer at a company and I want to make a change, right? But before I make a change, I want to kind of do a preview of the change to make sure everything looks good. And then when I'm ready, I want to promote that to production, right? So what you would do is that from the base layer, right, SQL Mesh exists. There's a production kind of view layer and then physical tables that those views interact with. So that's like the baseline. Then I'm going to then make a development environment, and this is free and instantaneous. So SQL Mesh will create a view layer, just like in production, pointing to the physical layer. So even though I have a complete copy of the production, no data has moved. Now, if you were to use a tool like dbt, this would have, been very expensive because you would have had to do dbt run to your development, essentially wasting compute, wasting storage. So now the interesting part here is now I make a change, right? I make a change to model A, and in development, we can create a model A snapshot too, which means that now my development is different from production, but we've only done one piece of work. We've created the new model A, but the model B is still shared, right? And so this is the most efficient way for you to kind of create development. And just real quick, this is a common question we get. It is not the same as Snowflake clone or Delta Lake. I forgot what Delta Lake's version is called, but this is all implemented with basic views, right? And so the reason we did that are a couple of reasons. One, every SQL engine supports views, right? And we wanted to make sure that no matter what engine, what warehouse you're using, this technology will work. Additionally, things like SQL Snowflake clone, they're very good at, if you have one table and you have kind of different versions of that table, it's good for that, but it's not good for really complicated branches, right? Snowflake zero copy cloning has some limitations, right? You can only go so deep, right? And then there's kind of a little bit of overhead with those clones. And so SQL Mesh's system of managing those kind of environments for you is much more automated, it's much more flexible, much more powerful.
Yeah, with any of those platforms, when they talk about their clones, it's used as a way to develop. But as you can see in this last slide, we actually take those clones that we produce and we put it into production, which you wouldn't want to do with a Snowflake clone or a Delta clone or anything like that, because we're making a complete new table.
Yeah. So one of the interesting aspects of this kind of system for SQL Mesh is when you make a development kind of view, right, you can actually go the opposite direction. So when you're ready, right? You can promote all this work that you've done back into production, right? Because it's just view swapping, right? You can do all your work safely, isolated, and then when you're ready to go to production, you just swap the views, and then boom, production instantly now has your work, right?
So we had a question, is each snapshot a view then?
So each snapshot is, okay, it's a little complicated, but snapshots can point to physical tables, but they can also point to views, right? And so the physical layer has tables, right? And each snapshot is a representation of a query, okay? SQL Mesh understands your queries and understands, for example, what columns are in there and what business logic is there. And so every unique query you have is a unique snapshot. Now, each snapshot can point to different physical tables through views, right?
Got it.
Yeah.
So that addresses the question from RP. But interestingly, before I go ahead, there's a question from Alex, which we can address now as well. Who's the person of a SQL Mesh data team or engineering team? I think that's very fundamental as well. Go ahead and take that question to be Ryan.
We built SQL Mesh for everyone. I think that the engineering teams are going to be the ones who kind of really reap the benefits because they're the ones who have to kind of scale existing systems. They're the ones who have to deal with the pain of managing existing transformation tools, right? But we're really also looking to cater towards the less technical folks like the analyst, etc. And as you'll see in the demo, Ryan will be using our open source and free IDE, which is catered towards the more non-technical users.
Got it.
And so all of this complicated system, the user doesn't really have to think about it. All of this is done under the hood. I'm just kind of showing this so you understand the nitty-gritty of the magic Ryan's about to show.
Perfect. And before we go, there's two more questions. I know that a lot of folks are raising hands as well, or pinging me on WhatsApp on my phone saying that, can I ask the question? So let's take one more question right now. I don't want to disturb the flow. We're definitely going to address all the questions. Good question from RP. I'm assuming it's Rajesh here. Dev versus prod, are we duplicating tables on which the model is operating? Are you copying the tables or just the code? That's the question that RP
Great question. So it depends, right? If you're making a change that requires a backfill, right, then of course we're going to have to duplicate it. There's no choice. However, SQL Mesh has the ability to understand when you don't need to do that. Right. And so in those cases, we don't duplicate. So Ryan will show you an example of that in the demo.
Got it. So I'll pause for the questions right now. Allow you to continue on the flow because these are questions probably you're addressing in your demo or in your slides. So we'll hold on for some more time.
Perfect. Thanks everyone for the questions too. Appreciate it. All right. So here for the demo, I'm showing our open source web IDE. This was recently launched as part of our open source offering. And but we also have other interfaces you can use. We have a notebook interface and a CLI interface. Now for this demo, what I'm going to go through, I'll give you a high level sense of what I'm going to do. So I'm going to create an RDev environment for me to make a change in. That's a clone of prod. I'm then going to apply a change to that. And you'll be able to see the difference between a breaking and non-breaking change. And I'll explain what that means. And then we'll promote that change to production. And then we'll end by rolling back that change out of prod. We'll assume that like there was an issue and I want to roll back. And I'll be doing all that using just the web IDE and what we call our plan apply flow, which you'll see me go through. And then after that, I'll give you a little sense of our open source CI/CD bot that's going to launch in about a week, I would estimate. And I'll show what that workflow looks like within a GitHub PR.
Wonderful, Ryan. Excited.
Great. So here you can see the IDE. And my first step is I'm going to create an RDev environment. So I'm going to type in RDev here. And then I'm going to run plan. So plan is the way that you interact with SQL Mesh. It's how you tell it that you want it to make the changes that you made locally represented in some environment. So here it says my target environment is RDev. And all the things that are in my code right now is exactly what's in production. So SQL Mesh is going through what we're calling a fingerprinting process to create those snapshots and sees that everything that's here has already been built in production. Therefore, we can do what it calls a virtual update, which means instead of building all these tables to represent it in RDev, it will just do the update to the views like we were showing in those graphs or those diagrams. I'll go ahead and apply that now. So virtual updates are always really cheap because we're just creating or updating views. So now I have my own RDev environment. Now I'm going to make a change and I'm going to add a column. And as I save this, you're going to see that SQL Mesh detects my change. It has a little summary up here. That lets you know that you have some pending changes in your local repo that haven't been reflected in that environment. What I could do is run plan, and now you'll see that SQL Mesh says that we have this non-breaking change. You can actually click in and see the summary and the diff of that change. And you can see here that we're adding this column, the rounded item price. And it has labeled this as a non-breaking change, which means that it recognized this is an additive change. We have added just a column to the table, meaning anything downstream of this table that exists today has completely valid data. What they have today can stay exactly the same. We have not changed what has existed before. Therefore, we don't have to rebuild those tables. The only table that needs to be rebuilt is this item D table. And you can see that down here in the backfill section. It's saying it just wants to backfill item D. Now, in comparison, I'll show you what a breaking change looks like. So what we'll do is do item price. So we're going to say we're only now in our dimension items that are greater than or equal to 6. And I'm going to run plan again. And you'll see we get the breaking change at the top. And you can see our diff reflects what we've added there in the filter. And now down here in the backfill, we have all 3 of these models. So it's telling us that we need to backfill item D and these order tables. And that's because this was a breaking change, meaning that they need to be rebuilt to correctly reflect not having prices less than 6, according to my filter, right? And SQL Mesh is able to do this categorization automatically because it's actually parsing and understanding your SQL. So it understands the semantic meaning and what it means from a breaking or non-breaking perspective. And it's also important to note that it's able to conclude breaking well beyond just structural changes. It also does it, as you can see here, with things like filters. So it's not just a structure check, it's actually looking at the characteristics of the data itself to determine that. Now I'll go ahead and apply this backfill. I think we have a question that I'll answer. It would be interesting to see how this works with the column name change or data type change. Yeah, same concept. Exact same flow. So you could change the structure, add a filter. For both of those, if you were to make those changes, they would be breaking changes that you would be applying.
Perfect. Probably we need to have a quiz on breaking versus non-breaking changes towards the end.
The best way, a shortcut to understand that is it's essentially if you add a column, that's non-breaking. If you're doing pretty much anything else, you're going to be breaking. Changing a type, adding a filter. So a lot, but you'd be surprised if you don't already think in this framing. Once you kind of do, it's often easy to put things into a non-breaking categorization. Like you might be looking to add a new metric and you'll think of a way like, how could I frame this metric as a new column within my table so I don't break things for downstream consumers, which is honestly just better for your data model and data ecosystem in general if you're introducing less breaking change into the system.
Got it. And I think you're also passing the SQL and showing this beautiful lineage.
Yes. Yeah. Thank you. And so this is actually this is very fresh. This is like a few days that we added this. So it's very new, but yes, now we show down here the DAG, which is correlated to what you're looking at. And we actually show the column level lineage. So for example, I could click on order amount here and you can see that it's based on quantity from this table, item price from here, which gets its value from item price from this table. So our goal here is to provide, as you're developing on your models, you could quickly get this wider context of what you're working in and understand those relationships and potentially what the impact would be as you make these changes.
So we had a question from RP. How do we recover from various breaking changes which are not going to be solved by backfill? I don't fully understand that question. Could you elaborate a little bit?
RP, probably you want to unmute your line and ask a question.
Hey guys. So for instance, just take an example of a column name change or a data type change, right? Now, obviously, if let's say there's a downstream table or a view that's using that, let's say a metric is built on top of it, right? Now this essentially would have two kind of solutions. One could be that you basically go and say, hey, replace all the downstream table column names. That could be one solution, right? The other solution would be just say, hey, pause here and let the developer look at it, right? So what I was curious about here was, how are you really handling, because this is one kind of a change which needs a different strategy, and this could probably go to data type as well, as what I was assuming. You're not going to be able to solve that by just backfill, is how I'm looking at it.
Right. So as you saw in Ryan's demo, when he runs plan with a breaking change, it knows the whole bag, the whole graph of things that depend on that model. And so it's going to backfill not only the table you changed, but all the downstream jobs. And so, yeah, you're going to have to change the downstream jobs in order to kind of leverage that new logic or the new schema. But SQL Mesh kind of informs you, like, hey, these downstream models are affected, and then once you make those changes, you can then easily backfill the whole graph.
What is backfill here? What is backfill here? Are you filling values in the table, or you're filling the models?
We're rerunning the whole tables, right? Because you've changed the logic, so we need to rerun the queries. Yeah.
And you're doing this on a dev setup, not the production. Is that correct?
Right. So we're using virtual environments here, and so you get access to all of your production data, but it's in an isolated dev environment. So any production dashboards pointing at the production tables won't be affected, but you're going to get the full fidelity of your data warehouse.
So the question, just an extended question, and I would pause for you to continue. So let's say DuckDB is my dev environment and Snowflake is my production in this case. So are you replicating the tables from Snowflake to DuckDB here?
No. So in that particular case, your Snowflake data is probably way too big for your laptop. So you're not going to be able to easily replicate that. And so this is all being done within Snowflake. But you can use DuckDB for things like unit testing. If you're interested in that, we can show it in the demo. It's not usually part of the demo, but we do support kind of testing in DuckDB while production and dev are in Snowflake.
Okay, so here's, if I just take it for the cases like this, I would still need my dev to be in Snowflake in a separate DB or something. Is that correct?
Right, and so this is common, right? Because it's difficult to do data development if you're not actually...
No, I'm just double confirming, because one of the things that I liked about this whole thing is the DuckDB piece and as a dev. And then the question really is, how much of it can you do with DuckDB and how much you cannot, is really the question.
You could dev most of the time in DuckDB, right? And so I guess since you're interested in this, Ryan, can you show? So here is you can explain this, Ryan.
Yeah, no problem. So we have our recommended way to solve the problem you're talking about is to write these unit tests. So here in YAML, you could define explicit inputs and expected outputs for a given model. And you can actually write the test for the whole end-to-end model or also individual CTE expressions. So you can actually test each one as you go through the transformation. And you just define these inputs and outputs, and it's running in the backend in DuckDB if that's how you configure it. So that gives you like a really quick iteration feedback of whether or not your change is valid from a logic perspective, right? Before you even think about deploying or running it in something like Snowflake. And then only if you pass those tests, then you can apply and create a development environment and go through the rest of the flow.
Yeah, I think that's wonderful.
Awesome.
And that's one of your greatest features. I would rate it as well, because if you're wanting to do local testing or development and you want to run on a cheaper alternative, or low cost alternative, go ahead. Right. So in that case, will you still do the replication? That's a question I have. Or
the only thing that I want to add to what Ashwin is saying is that obviously the level of skill you need to write this test would be a little more than a general analyst who probably doesn't have that time, I guess.
Right.
Yeah. Sorry.
The nice thing is that an engineer or a data engineer can write these unit tests and then have them always run in CI. And that way, when a kind of less savvy analyst makes changes, CI will catch these changes and the data engineer can be like, hey, did you really intend to change this column, right? And so it's like one of the first times where you can actually unit test your SQL queries in CI.
Also, really think of this as our first pass on this implementation. We can obviously create a bunch of tooling, especially in our custom IDE, to make developing tests a lot easier. So, and that's something we would love to get feedback on.
One of the things that I don't know if it makes sense, probably a little more work, but maybe what would make sense is to, let's say, create a sampled version of table from prod to dev, sort of a sync state, if you want to think of it that way. It may not be complete, but it would probably save people from writing the test cases in many cases.
Yeah, Toby and I had tooling like this in our past at companies we've worked at. So that's something we've talked about before. The only thing I'd caution there, when you just sample data out of what exists in prod, you're not really necessarily designing like specific edge cases. Like if you think about it, software with unit tests,
absolutely,
think about specific behavior you're expecting. So, but that could really help with like, I have nothing currently, let's get a base foundation, and then I'll tune it here, I'll cover these edge cases. Right.
Absolutely. I don't think it will substitute what you have. It probably would get somebody started quickly, that's all.
Yeah, absolutely.
Yeah.
That's just one example.
Yeah, we'll take one question. I think Gabriel had one. I think we kind of spoke about it. Definition of a snapshot is equal to set of views plus their SQL Mesh proprietary metadata then. That's the question. So is it a set of views and some proprietary metadata that you would end up creating at the backend?
So a snapshot is the metadata associated with a model as well as all their upstream. Views are really, there's another term that we call it an environment. And an environment is a collection of views that are correlated with snapshots that point to physical tables. It's a little bit nuanced.
You need to write it down for us to understand it. I think we'll point to the documentation to be post the session, and that will clarify some of these definitions.
Yeah, I think important thing to point out here though is that for end users, people using this, they may think they're just querying tables. Like our views look like normal tables. You don't have to know about any of this if you don't want to. And obviously, as an engineer or if you're in the platform side, you'd obviously want to understand it. And we have tons of documentation. But I just want to make it clear that this whole, is this a snapshot? Is it a table? Is it a view? Isn't something a user needs to worry about. To them, they're just querying their models. They're querying their tables. It's all magic behind the scenes.
All right. That's the questions that we have. Go ahead, Ryan.
Great. So where we are in the demo is we applied this change. I have it in RDev, and now I want to promote it to prod. So what I'll do is come up here, select prod, and then you'll see that it correctly detected that I have these changes that it represented in my repo that haven't been applied to prod. Very similar to before. What I would do is do run, and you'll see that it detects the breaking change. So it's saying we're trying to apply this. We've seen this before, right? With the adding the column and then adding the filter. It's breaking, right? Which is all the same. The key difference, though, is now we get a virtual update. So back in RDev, I actually built these tables, but SQL Mesh has now detected that I've already built what I want to apply to prod, and we can just update our views in prod to use those tables rather than build them again. So I can apply a virtual update. So this is saving yet another rebuild that we would have had to normally do by just doing the virtual update. And this is the key concept, is that we are able to bidirectionally do this kind of sharing. So we can, when I created RDev, I did a virtual update to create the replica. I then worked in there in isolation, and then I promoted to prod, and I was able to use that same exact flow, that technology, to then get that into production. So it goes both ways, which is very unique to SQL Mesh. Now, one last thing I want to show in the IDE is, let's say I deployed this to prod. I'm now at home. I'm sleeping. I get some alert at midnight. Something's gone horribly wrong. Not sure what happened. And I don't want to triage at midnight. I'll deal with it in the morning. I just want to get us back to a stable state, right? So I might just go to my Git repo. I'd probably do like a Git reset. I'm just going to delete these things for the demoing purposes. Delete that out. And then now you can see I have my changes, and I'm going to run against prod. And now you'll see that we actually got another virtual update. So SQL Mesh knows that it's seen this exact logic before. This is what prod was before we applied the change. And it actually keeps these prior versions of these tables around for about a week. We have what's called a janitor that will clean them up, and you can schedule the amount of time you want to keep old tables around. And so when it saw that we've seen this logic before, and it already has a table we could use, it's now using that same technology to now virtually update us to that previous table. And what this means is now when you deploy to prod, you have a built-in easy way to roll back to a prior stable state if needed, if something's gone wrong, very quickly. So I can apply that, we're done, and now we're back to a stable state, and now I can go to sleep and wake up in the morning and go ahead and deal with the problem and figure out what happened then.
Great.
So that's it for the web IDE. I'm just going to jump over now to look at a bit of our CI/CD bot. So this is this is in development. We're going to launch this very soon, I think in about a week. So I have to show this video form because I'm making a lot of changes. But in this example, you can see I opened a PR with a code change, and I made a pricing change. And what SQL Mesh has done, as you can see in this box, it went ahead and created for us a development environment. And it's an exact representation of the logic in this PR. So I know as the reviewer, if I come in and so this person comes and says, hey, can you check out my PR? I can go and see the exact code. But I also know if I want to see what that data looks like, I'm guaranteed that that environment represents the data, the code that is in this PR. Which maybe if you used other systems, maybe I create a dev environment and I say, hey, can you check out dev? Maybe I applied something after I forgot, and now I'm looking at something I didn't expect, right? This is a hard contract between me and the system to know that what I'm looking at is in the PR. And so I can review the actual data in that PR. And then let's say I go ahead and do an approval. This would be, it just says SQL Mesh. That was for simplicity, but that would be me, the reviewer. I approve it. And then SQL Mesh, as you can see at the bottom here, will then start with the next set of automation. So it has update PR environment, gatekeeper approval, and deploy to prod. And so what SQL Mesh is going to do is see that the approval came in. So that's the gatekeeper approval it's looking for. That's the signal it uses that it needs to go to production. So then it kicks off a job to deploy what we have here into prod. But a really critical thing it does is that it makes sure that whatever's in dev right now is at data parity with what's in prod. Meaning, like, let's say in prod, we've loaded data through the 25th. It will make sure that whatever we're promoting in dev is also loaded through the 25th. We actually track and understand the exact dates that have been loaded into every table in order to do that. And if it's behind, so let's say in dev, I only loaded like a month's worth of data because I didn't want to do the full backfill. I just kind of wanted to sample. SQL Mesh will detect that we don't have the full data set. It will automatically kick off a backfill to fill it in. And then only once it's fully backfilled, it will then deploy that to prod. And even more, after it deploys to prod, it auto merges this branch into main. And that characteristic is a key goal for us, is that we want the main branch of your repo to be tightly coupled to the actual data in production. And so by actually deploying to prod and then merging ourselves right after, you know when you look at the main branch of this repo that you're actually looking at the code that represents the prod state. Unlike normal systems where you might merge to main and then a build kicks off sometime later to reflect that, right? And you never really know, is the code I'm looking at in main, has this been reflected yet? Is this a state that we've realized? You don't really know because there's not some tight coupling there. Well, we were able to achieve that using this system. And that's really all because of that virtual update, yet again, that we've talked about with the virtual data environments. That very seamless, quick deploy allows us to do stuff like this.
Perfect.
So yeah, that's the end of what we had scheduled for the demo. Would love to take any further questions people may have.
I open the floor right now. Any questions from anyone? Please unmute your line. Go ahead.
This is Rajesh again. I would probably have a question here. Since you guys keep track of all the downstream views and snapshots, the question that I would have is there a case where you have, where you're going to hit the scale issues here? Let's say you have thousands of views and procedures. How are you really, have you really thought about that, or is that something that's already taken care of?
That was one of the questions I had for them as well, right? Probably.
Yeah, so a couple things here. One is the foundation of this technology has already been proven out at scale, right? This is used at Airbnb, where they have 30,000 models everywhere, right? And so I'm sure most companies aren't at that scale. Now, in terms of enhancements we're going to do to make, dev environment a little faster, we're going to in the future have things like selectors so that you only build a certain subgraph, right? To make things a little bit faster.
Got it.
Answer your question?
Yep.
Yeah. It does, yeah.
Alex Hauer asks, can you walk us through a practical application of SQL Mesh? Like you're trying to build an ELT pipeline to get access to multiple SaaS data sources for financial or marketing reporting.
Oh, that's a good way of putting and explaining SQL Mesh.
So SQL Mesh can be used anytime where you have a data pipeline where you want to run SQL or Python code, like in a graph to do stuff, right? And so as an example, I don't know, are you looking for like a particular use case or like, because like,
so,
yeah.
Let me rephrase the question for you, right? So, like if I'm having SQL code, or let's say Python code, ELT is simple. It can be a Python code also. Let's for the sake of simplicity of this audience take SQL code. And how do I bring in SQL Mesh into the picture, right? So let's say I have 10 different SQL codes that does some operations for the purpose of, let's say, financial or marketing reporting. How does SQL Mesh work? I think that's what I think Alex is asking. To get access part can be part of a Python code in case you want to read data and all that. That's part of the code. But then let's focus only on the code part and how does SQL Mesh fit in there? I think that's the question.
Okay. So if you are already using a tool like Airflow where you have these custom scripts, you would just put those scripts into the SQL Mesh kind of models folder, and then you would format it a little bit differently so that you have some metadata so that we can know like who owns the job, how often you want it to run, right? Once you get it into...
Is that how you build the lineage also? Like when you show the lineage, is that how you're building? So if I give you the Airflow models, are you building the lineage from there?
So if you write SQL code, we parse the SQL and can figure out the lineage. If you write Python code, we parse your Python code to figure out the lineage. In Airflow, in tools like dbt, you have to manually tell the systems what the DAG is. We do not have to do that. As you can see here in this example, there is no ref. There is no dependencies. We just understand the SQL and like, oh, source menu item details. That must be the parent, right? And so that whole lineage is built from parsing the SQL, even the column level lineage. Just someone in the channel as well asked.
Just from one SQL, or you parse multiple SQLs and then build a 360-degree lineage? Because when it comes to lineage, the most popular pattern that we have seen in industry is use a metadata management tool or an open metadata or an enterprise data class, data catalog to kind of build that into it. How are you building? Is it just based on that particular SQL? I'm assuming it's not, because I can see more tables here over here.
Right. So all of the models that are represented in this project are in SQL Mesh. And so we parse all of that SQL. Now, one thing to note is that if you're just using a metastore kind of system, you're not going to really get fully column level lineage, right? Because, for example, as you can see in our lineage, we understand that if you have like two upstream tables and you add them together, that creates a new column, right? And that can really only be seen through the actual SQL code. You have to understand that, you did A plus B to make C, right? In order to fully understand like real column level lineage.
Yeah. For the full, yes. I think for the purpose of navigating through that SQL, editing that SQL, I think whatever information you're showing is sufficient.
Yeah, someone was curious about Python models, so Ryan, want to show that?
Yeah. So Python models conceptually similar to SQL in that the contract with that is that you just have to return a data frame. It can either be a pandas data frame or a PySpark data frame. And you just put this annotation at the top or decorator at the top to define your different properties, just like on a SQL model. So here we're saying this is incremental. We have this cron scheduling, right? Very similar to before. And then we actually, to do the the table lineage, we actually parse out. So you can go get your table name by doing context.table. And you can see that our parser actually detected that these are your dependencies. You can click into them to see what they are. And that's how we're doing the lineage here. So yet again, you had to get these table names anyway, so we're reusing that to understand your dependency graph. And then you can do all your Python.
I just have a question here. I see a lot of Python code here with the SQL somewhere, right? So are you also parsing the Python code here, for instance? Below?
Yes, that's correct. We're parsing the Python in order to get your dependencies like this.
Okay, it's not just a SQL that I see in the fetch df. You're parsing the whole thing.
Yeah.
Yes.
Okay.
But we only, but as Toby was saying, for the column level lineage, we only deeply understand, because like you could do anything in Python, right? We can't understand fully all these pandas operations. So we can't know the details of what's going on there, but we can understand the full end-to-end details of your SQL models.
That's right.
Yeah. A lot more easier as well. Somebody just asked in terms of why did you end up building SQL Mesh? Like what was the challenges that customers came back to you with? So I want to take that question. Okay, it's sent to me privately. So yeah. What are the challenges for DataOps and why did you end up building SQL Mesh?
So we've kind of all been in this space for a while, working on data pipelines, experimentation, metrics. And so we've kind of been in the business of making it easier for scientists and analysts to deliver business impact. And so we've all kind of seen demos of DBT. And so we all kind of felt like we wanted a tool like that at our companies because we saw how big of an impact DBT had on the analytics community. But we wanted something that could work at any company, any of the companies that we worked at, meaning there's more models, there's more people, there's more data. And so we built SQL Mesh from the ground up, kind of as the next evolution of DBT in order to handle all of these kind of vectors of scale.
Got it. Now, since we're talking about DBT and one particular announcement from DBT from last week was around a contract first approach as well. What's your view on that, Toby? I know you've written on LinkedIn, but I wanted to take your view as well. And in your introductory slide about SQL Mesh, you also spoke about your contracts as the third pillar that you support. And how does that come into picture as well?
So there's a couple of parts here. First part is that we wanted data contracts to kind of be automatic. We didn't want yet another YAML file to kind of have to define that. We really believe that your code is the source of truth. And so we did everything that we can to kind of make kind of your code, the types that you find in your SQL, to be the contract. And whenever you change those things, we'll let you know, right? As you saw in the demo, when Ryan changed or added a column, like we let you know about that and what those break and what those break downstream. So, oh, go on. Did someone want to say?
Yes. Go ahead.
Okay. And so the other thing is that, so DBT contracts, I think they're kind of a good step in the right direction, but they don't really solve the full picture, right? So DBT contracts are just schema based, meaning you can define expected names of the columns and expected types of the columns. So if you change the type, it would catch that. However, let's say you had a column that was an A, like 1+1, right? And so the type is an int and the logic is 1+1. Now, if you change that column to be 1+2, is it the same? DBT would think it's the same because it's still an integer and the name is the same. But obviously 1+1 is not equal to 1+2, right? And so in order to really have a data contract, it's not just the schema. You need to understand the business logic, right? And so SQL Mesh can understand that. And then the last point I want to make about the whole DBT contracts announcement is the whole versioning aspect of things. I think versioning is very nuanced and there's a lot of pitfalls to that. I think people see versioning in kind of the microservices world and think, oh, well, we should just have versions in data. I don't think it's that simple, right? One of our company's core tenets is that no data is better than bad data, right? There's like nothing worse you can do in data than to go to an executive and give them a wrong number. It's better to say, hey, my pipelines are broken. Give me a couple hours. I need to fix it. As opposed to, oh, here's how much revenue we made and we're off by like 10%, right? And so in a world where you version data and you have people like choosing old versions of data, it's going to be inconsistent. Every dashboard is going to be sourcing from a different version and you're not going to know what the numbers mean, right? And so we've taken kind of a different philosophy in that we try to make it as easy as possible to make sure downstream, all of your models are kind of up to date and use the latest definitions. Now, there's always cases where sometimes you really need to use an older version of something. And so in that case, we're no different from what DBT offers. You can just create a copy of your model, call it V2, and then use the old one downstream, right? But I think we need to do a little bit more thinking as a community on, the best way to do versioning, but to also make sure that your data is consistent.
Got it. I think you laid a thing about trustability in data, which brings me back to another question. I have one more on the contract, but I'll come back to the contract in a bit. Is around, you showed the lineage in your SQL interface that you showed me. Would you also be able to show, or is it part of your roadmap to show profiling information, observability on the type of tables that are being queried upon? Because you should be able to pick it up from metadata and display that on the CLI.
Yeah, so those are kind of things that we're looking to do in our enterprise offering. A lot of those observability pieces, metadata tracking cost, right? Those are things that we're looking to build in our enterprise offering. So everything you've seen here so far is all open source.
Okay, got it. But then that's in the plans in your enterprise offerings.
Yeah.
Perfect. And coming back to the contracts, what and how should people implement a contract first approach? You've got influencers like Chad having their own version of how to implement contracts. Anand, who runs Schemata, again has a way of implementing data contracts. How do you think, Toby or Ryan, you want to take the question? So how should people implement data contract? A contract first approach. In the API world, back in the days, we used to have API contracts, right? Then Ramel came in, Swagger, OAS, and all that. We had standardization on how API specs were written. How do you think, and how do you envisage data contracts to be implemented?
Are you guys familiar with like Fast API, which is like a Python library for making web apps, right? We want to make it so that kind of the data contracts are really tied to your code. And so when you write a SQL query, that's your contract, right? And we can automatically, from your SQL code, create a contract. And whenever you make or break those contracts, we'll let you know. And and so I think there's two parts. One, we automatically convert your SQL into a contract. And two, you write unit tests, right? You need to write unit tests on models that have strict API guarantees to make sure that anyone who changes it in the future is stopped and validated by your unit test, right? It's not enough to just have schema as your contract. You also need to have business logic as a part of your contract.
Got it. And for quality checks, again, you've got great expectations, you've got SODA and tools like that. How do you think people should implement it on top of SQL Mesh? Like, should they integrate with expectations, write an expectation, and then integrate it back here? Like, I know Ryan showcased a pattern of expectation within a YAML again. Right?
So we have both data quality checks. We call them audits. Data quality checks are what everybody else does. Great expectations, DBT, they all have these data quality checks, things like checking nulls, etc. And so we have those as well. The addition that we have is unit test, where you actually defined inputs and outputs, which can then be run in CI. And so we believe you need both in order to have high quality data.
Got it. So which brings me to the next mix of question around. So then SQL Mesh is not just for people who are involved in the CI/CD process, but then as part of a data engineer's data analyst life cycle every single day, because then they know whatever they're writing is breaking a contract, breaking an expectation. Is that how you're thinking SQL Mesh should be implemented as well?
Yeah, absolutely.
For full-fledged enterprise.
Yeah, we think anybody who touches SQL, who writes data pipelines, will benefit from SQL Mesh, right? I think that platform engineers, the data engineers are going to love our ability to do things right, ability to test things. And I think the data scientists and analysts are going to love that they won't have to think about things as much. They can easily run concurrent backfills without thinking about them. They can easily create a dev environment and validate a machine learning model without having to deal with figuring out how to get the data in the right place, right? And we think that the executive is going to love being able to look at, what happens when I change the definition of revenue? What does that look like, right? And with our virtual environments, they're going to be able to point their Tableau dashboard or their Excel report at this dev environment with this new definition without touching the real report that goes to the SCC or whatever, right?
Got it. One final question from my end, and I'll open up the forum to see if there are any other questions. This whole notion of data products, it's been a hot topic in most of my data conversations around the world. So what's your viewpoint, Toby, Ryan, in terms of what's your view on data products? How do you think data products as an architectural framework, as a design framework, is going to shape the data space?
So the question was, how do we think data products are going to shape?
How do you think personally, like not about SQL Mesh, but then how does Toby think personally, or Ryan? Right. So what's your view on data products? And data or data as a product, whatever one. Most you use both of them interchangeably.
I think everybody wants to reap the benefits of data, right? They want to understand data, they want to make decisions from data, and they want to benefit from it through like search and recommendations and machine learning, right? So I think that as time has progressed, people have understood and wanted to reap the value of data more. But as a consequence of this, I think people have realized how difficult it is to produce data products correctly and efficiently, right? And so that's kind of where we come in. And we're trying to make it easier for any company of any scale to make correct and efficient data products.
Yeah, you could think of, if you remember our slides, we had those indices of growth, right? One of them was more use cases. And that's exactly what we're thinking about here when we think about the growth of data products and data use cases, is that the companies are finding more and more ways to differentiate or get value from data. And really what SQL Mesh is trying to do is to make it to where it's very efficient and easy for your team to grow to those needs. So as new use cases come up, you can easily deploy those new pipelines. As long as deploying a pipeline at your company is an expensive process, right? It's something that takes a long time to coordinate and get out there, or expensive to maintain. It's going to limit your growth of use cases and therefore limit the type of data products you can produce. So we need to find ways to like automate and trivialize this process as much as we can, which is what SQL Mesh is trying to do.
Perfect. Thank you, answers. Any other questions from the group? You can probably unmute your line and ask that question.
I can reply to something in here about versioning is important for data science and tracking training and test drift over time. I want to comment that's a bit different in my mind than what the contract versioning that we're talking about. So you could do, for example, if you needed versions of your data over history, you could do like snapshots with historical snapshots maintained to know your snapshot history. If you wanted to maintain different versions of metrics, you could version your actual metrics or columns. So you might have daily active user V1 and the daily active user V2. These are all types of versionings that are that can work perfectly fine. The versioning we're talking about is where you have completely different sources of truth of what like users even is. That's the type of versioning that DBT is talking about, where I have users as a concept V1 and users V2. We could source for them seamlessly or differently throughout our whole data ecosystem. And we're saying that inconsistency can cause problems, right? I could put up a dashboard that shows daily active users that's different than some other data product. And when the business says, hey, why are these different? You say, oh, did you use users V1 or V2? And now that person's like trying to comb through their logic to figure out what they even used, right? That's the world. That's the nightmare we're trying to avoid. And that's what we're meaning when we talk about versioning in that context.
Perfect. Any questions from the group? I have one question. Like, how do people get started on SQL Mesh? Toby, Ryan, quick summary on where they can
go to SQLmesh.com and there's a link to get started. And so it's a simple pip install. You can then follow the instructions and do a sample project on top of DuckDB. So you can get started very quickly.
Again, small request from my end. This month has been a lot of open source discussions in Real Heroes community. So if you try out SQL Mesh, please do start the project. I find it very interesting. I think we should definitely show our love and appreciation for all the effort Ryan, Toby, and the rest of the team have been doing at the SQL Mesh project, right? So any final questions for Toby and Ryan? Please unmute your line in case you want to type it, unmute your line and to share your inputs or your questions, or could be any random comment because we're just 2 minutes to close. Okay, going. Okay, thanks, Adil. Okay, perfect. I don't see any questions yet. Okay, somebody's pinging me on WhatsApp and saying I would ping you later and ask my question. So great, you can do it. I'll ping Toby back and try and get you the answers. Remember to subscribe to our YouTube and LinkedIn channels as well, and also go to SQL Mesh on the GitHub project and start them as well. Thank you, Toby. Thank you, Ryan, for joining us, and thank you everyone who stayed till the end of the call today. We had a good attendance, 27 at a peak and 17 right now. Thank you for patiently waiting till the end of the session. I hope you learned something new around how you can approach different problems with data. And that's essentially what this community has always been about. I found this interesting, and hopefully you learned something new. I definitely have 2 or 3 pointers that I picked up from the demo that Ryan gave me and around the wonderful things that the SQL Mesh project is building up for, right? Thank you, everyone. Thanks, Toby and Ryan, for your time today.
Thanks everyone.
Thank you, everyone. Bye-bye.